welcome to this explainer. Okay, if you're a B.Tech first semester student right now, I bet that jump from basic programming to data structures and algorithms feels, well, it feels kind of like hitting a brick wall, right? Suddenly, everything's abstract, the code makes zero sense, and the errors are everywhere. But don't worry. Today, we're demystifying DSA by zeroing in on 3 specific beginner mistakes in arrays and stacks. These are the exact traps costing you precious internal marks, and we're going to give you the straightforward fixes to completely ace your exams.
Look at this quote from the experts at Naresh IT. It honestly hits the nail on the head. If you're struggling with C or Java, hear this. It is absolutely not because you lack intelligence. It's literally just your approach. Shifting that learning strategy, that is the secret to turning all that confusion into total clarity.
So here's our roadmap for today. We'll quickly cover why DSA feels so hard, then we'll hit mistake 1 on array bounds, mistake 2 on the reading versus running trap, and mistake 3 on stacks. Finally, we'll wrap up with the pro mindset.
Let's start with part 1, why DSA feels so hard and why it feels like hitting a wall.
The biggest trap I see beginners fall into, treating data structures like just another college theory subject. You know, memorizing definitions to pass a written test. But for real problem solving, you have to visualize how data actually moves inside physical memory. If you don't grasp how data lives on the hardware level, advanced topics are basically just guesswork. You really need to train your brain to truly see the data, not just remember the definitions.
Let's jump into mistake number 1, out-of-bounds arrays.
This is a huge one. Notice the stark difference between C and Java here. Java is almost polite, right? It gives you this loud, beautiful exception when you step out of bounds. It stops the program and tells you exactly what went wrong. But C was built for speed, and it assumes you know exactly what you're doing. So if you step out of bounds, C just blindly accesses whatever garbage memory is sitting there. You get silent, undefined behavior, memory corruption, and unpredictable crashes that are an absolute nightmare to debug late at night.
Think about it like this. If your array is size 10, it legally owns slots 0 through 9. But in C, if you ask for index 10 or 11, the program doesn't stop you. It just marches right past the boundary and scoops up whatever random data or even protected system instructions happen to be sitting in that next memory slot. You are literally messing with memory you have absolutely no business touching.
So memory boundaries are rigid, which brings us to mistake number 2, the reading versus running trap.
The dev community brought up an incredible point here. The single biggest mistake beginners make is reading their code instead of running it. Why? Because your brain is a master at filling in the blanks. When you read your code, you project your intent. You assume it naturally does what you meant it to do instead of what's actually written on the screen. To dry run effectively, you literally have to become a dumb machine. You don't know what the code should do, you only know exactly what it does.
And this mental projection, it's exactly what causes off-by-one errors. Your brain acts like a super aggressive autocorrect. Say you meant to write less than or equal to, but you only typed less than. Your brain will literally read it as correct because that was your intent. It'll trick you into skipping the final loop iteration or ignoring that a variable scope resets inside a loop. These silent, invisible logical errors are what completely tank your exam scores.
So how do we fix it? First, read your symbols out loud. Seriously, literally say the words less than or equal to out loud. Hearing it breaks the illusion and catches the typo. Second, never ever skip that final loop iteration. That last cycle is where off-by-one errors live. You have to manually dry run that final check and trace the exact moment the condition becomes false without skipping a single step.
Okay, moving on to mistake 3, treating stacks as theory.
You've probably seen this definition in the MRC ET manual. Stacks are LIFO, last in, first out. It's a linear data structure where all the action happens at the top. Now, memorizing that acronym might get you a point on a written exam, but it's really not going to help you build one in a coding lab or survive a technical interview.
Instead, you need a physical mental model. I absolutely love the tennis ball can analogy from AI and ML Insights. Imagine dropping 3 tennis balls into a tight cylindrical tube. You physically cannot reach the bottom ball without pulling out the ones on top first, right? Visualizing this turns abstract code into a physical reality. When you call the push function, you're just dropping a ball into the tube. When you call pop, you're taking the top one off. It's as simple as that.
And because we only ever interact with the very top of that tube, whether we build it with arrays or linked lists, we never have to shift a whole line of data around like we would in a standard array. That means push, pop, and peek operations all run in super efficient O of 1 constant time.
When you visualize it like a physical object, that blazing fast performance totally makes sense.
All right, let's wrap this up with the resolution and building your pro problem solver mindset.
Let's bring it all together to save those internal marks. First, respect your physical memory boundaries, especially in C. Don't go walking off the edge of your array into garbage data. Second, dry run your code manually like a dumb machine. Do not let your brain autocorrect your typos. And third, always attach real-world models to abstract concepts, like that tennis ball cam. That is how you go from a stressed-out student to a pro problem solver.
So as you head into your next coding lab, I want to leave you with this. When you sit down to debug, are you just passively reading your code, hoping to spot a typo, or are you actually running it like a machine? Apply these visualization techniques, respect your boundaries, and you won't just survive your internals, you'll completely crush them. Thanks for tuning in to this explainer.